Okay, we can start. In your syllabus, you have to study about what is continental drift. That is the main topic that you have to understand. To understand that continental drift, we have to first know some features about the structure of the earth as well as about regarding the continents. Going to the structure of the earth, this is something you have studied from your high school classes also. That is, earth is divided into three main layers. On the outermost layer is known by the name crust. Here you can eat just like an apple. The apple will be having a very thin outer layer, and that outer layer may be a few kilometers only in depth. That is known by the name crust of the earth. Then you can find a reddish region. That reddish region is known by the name mantle. So when a volcano is exploding, you can find that an yellowish molten magma is coming out. So that is the mantle. So it is the molten or liquid portion. That is, rocks are in a liquid portion. The temperature will be very high. All the rocks are in a liquid portion. They won't be solid because temperature is very high. Now going to the innermost layer, we have a core is there. That is the innermost. We don't know much about the core, but regarding the mantle, we have some idea. And regarding the core, we don't have so much idea because only thing we know that it is the temperature inside the core may be around 5,000 degrees centigrade. The 5,000 degrees centigrade means it is the temperature on the outer surface of the sun. So you can imagine how much hot it is inside the center of the earth. Now here you can see that. So we are mainly concerned about the crust. You can see that crust is the outermost layer of the earth. Now going to the crust, we can again see that there are two types of crust. One is known by the name continental crust and other is known by the name oceanic crust. Here you can see that. This is the continental crust and this is the oceanic crust. To put it in a very simple manner, we can see that the crust present above land area are known as the continental crust, and crust seen below the ocean or in the oceanic region are known by the name oceanic crust. So, in the case of oceanic crust, we can find ocean above it. In the case of continental crust, we can find land area above it. Now, there is also some difference in the thickness of the crust. So, coming to the continental crust, its thickness will be is more thicker. Here you can see that. So, above the continental crust, we can mostly find continents or land, and its thickness will be 10 kilometers to 70 kilometers in thickness. So, if you compare that with oceanic crust is very thick. So it is only 7 kilometers, approximately 7 kilometers in thickness. Another difference that we can find between the continental crust and the oceanic crust is the continental crust is less dense. Less dense means or more buoyant. That is the meaning than compared with the oceanic crust. Whereas the oceanic crust is more denser. The density, regarding the density, or you can simply say that the oceanic crust is more closely or more tightly packed, whereas the ocean continental crust is not so tightly packed. It has less density compared with the ocean. So there is one basic difference between continental crust as well as oceanic crust. And here also you can see that regarding the nature, it is this continental crust. It is more older, whereas the oceanic crust is comparatively more younger. So that is the difference in the age of age. So if you take the age of the continental crust and oceanic crust, we can find that continental crust are more older, whereas oceanic crust are more younger. These are some of the basic difference between continental crust and oceanic crust. Now, here what we have to study is about the continental drift. we have to get an idea what do you mean by continental crust. It's simply the movements of continents relative to one another. Drift actually means movement. That is, the on the surface of the earth, the continents are moving. You can imagine a football. A football is actually formed of several small leather pieces which are stick together. Just like that, the outer surface of the earth is almost like a football, formed of several small pieces. And each such small pieces are known by the name plates. Here you can see that somewhere here I will show you that. The outer surface of the earth will be, so this is how the outer surface of the earth will be appearing. The outer surface of the earth is formed of several small pieces like this, and each piece is known by the name plate. Some of the plates are carrying continents, so they are known by the continental plates. Here you can see that, for example, this of Arabian plate. There is an Arabian land is there. Then similarly we have Indian plate. Indian subcontinent or Indian region is above the Indian plate. Whereas some of the plates, Nazca plate, that is an oceanic plate. There are no land or continent above it. So based on that, we have the surface of the earth is actually formed of several small pieces, and these pieces are actually very tightly packed with each other. Another peculiarity is that these pieces can move relative to one another. That is, this is the Australian plate and this is a Pacific plate. Sometimes there will be, it is like this is one plate and this is another plate. They will be moving slightly in this way. When that kind of movement is there, that will result in what is called earthquake. The earthquake is taking place because of this movement of plate with regard to one another. Another major problem is that sometimes they are closely packed here. Sometimes they will be moving away. And what will be the effect? The mantle which is present below that will be coming out and that will be forming a volcanic mountain. So this is how the volcanic eruptions are taking place. So when two closely packed plates are moving away, there will be the eruption of volcanic magma from that area that will result in the formation of volcanic mountain. So if we look at the surface of the earth or the geology of the earth, we can find all these things. So in the case of continental, what we have to study is about the continental drift. It is simply this movement of these plates with regard to one another. When one plate is moving with regard to another plate, we can find there will be earthquake or there will be some tsunamis will be forming. All these are the result of movement of plates with regard to one another. Then we have to see what this continental drift has actually this theory was proposed by Alfred Wegener in 1912. So it was Alfred Wegener. Here you can see the Alfred Wegener. He proposed this theory called continental drift, that continents are slowly drifting around the earth or on the surface. Drifting simply means floating or moving. So they are slow floating or moving on the surface of the earth, because here you can see that this is a liquid portion. This molten mantle is actually liquid in nature, but this crust is solid in nature. So it is just like some boat is floating on the surface of a ocean or on the on the surface of water. Just like that, these continents are actually slowly floating or slowly drifting on the surface of this liquid mantle. So that is how regarding the nature of the earth crust. Now another thing that is that this idea was in the recent times it was proposed by Alfred Wegener, but it was in 1596 another person. Here you can see that another person named Abraham Ortelius. And Abraham Ortelius in his in 1570 He was the first person to imagine that continents were joined together before drifting to their present position. Here he can see this is a map drawn by Abraham Ortelius in 1570. You can see that. Still, this map is very much similar to the modern map, except not this American, South American continent. Most of the other continents are somewhat similar to the modern map. So that was around 500 years back they have drawn this map. But still, even at that time, Ortelius put forward the theory that the continents are joined together and they are also moving slowly away from each other. And in 1912, Alfred Wegener put forward the theory known by the name Continental Drift. Even though in 1912 he put forward that theory, it was not accepted, widely accepted at that time. Only in 1950, based on several new evidences, basically evidence coming from paleomagnetism. You might have heard about that paleo Earth as a magnetic field. Right now, you might have you know about the North Pole as well as South Pole. The North Pole is on the northern and most northern part of that is in Arctic region, and South Pole is in Antarctic region. That is the present situation. Now, if you study physics of the Earth, especially the physics of the ancient Earth, we can find that though the North Pole is in the northern part of the Earth right now, earlier it was not like that. Sometimes North Pole may be on the eastern portion of the Earth. Sometimes the magnetic north were on the southern Antarctic region also. And this drifting of magnetic North Pole and South Pole has been studied by scientists, and these are all the part of paleomagnet. Paleo means concerned with the old. How magnetic field of the earth has is changing. So based on those studies, now we have enough evidence to prove that the crust is actually floating on a mantle, or that the continents and oceans are slowly moving. And we will be finding more evidences in this direction. Here you can see that according to Wegener continental drift theory, there existed one big landmass. That landmass was known by the name Pangea. Here I will show you a diagram. So this was the ancient continent. All the continents were joined together. What was the situation? That was in 2225 million years ago. We are finding that all the continents are together joined together into a single large continent or a large landmass. Here you can see that this is the Indian continent, this is the Antarctic continent, this is the Australian continent, this is called African continent, this is the South America, this is the North America, this is the Europe and Asia. So all these continents were together at one time. Now, after 25 years, that is around 200 million years ago, during the Triassic period, a small separation came into existence. And here you can see that there is a northern continent. This northern continent is known by the Laurasia. Laurasia basically consists of Europe and present Asia, most of the Asian region. Whereas the remaining continents like South America, Africa, India, Antarctica, Australia, they were all connected with each other and they are known as Gondwana land. So that is around 200 million years ago. We are finding that two major continents. One is Laurasia and other is Gondwana land. And in between, we are finding a sea. That sea is known as Tethys Sea. The name of that sea is known as Tethys Sea. Now, what happened in 135 years ago? That is Jurassic period. During the time of Jurassic period, this separation has actually gone more. This splitting process has taken place. Now you can see that the India has is now like an island. It is moving moving away from the Antarctic region. Earlier, it was close to Antarctica. Even now, if you examine the fossil evidence or the rock evidences, we can find some of the rocks present in Antarctic region are also present in Indian region. We need to explain that. How can we explain that? And similarly, you are also finding that this African continent and South American continent are tightly packed. Here you can see that. Now in the present day South America, if you examine the rocks here and also the rocks here, we can find that they are geologically similar. That is, they are the rocks and soils are similar. Not only rocks and soils are similar, even animals and plants are also similar. So we need to have a proper explanation. The only explanation we can give for the present day similarity of the rocks, soil, plants, and animals that is present on the eastern portion of South America and also on the western portion of Africa is that they were once together. Now we have evidences, geological evidences, and other kinds of evidences that we have from magnetic studies also we have. So here you can see that this once around Jurassic period. Jurassic period is a period when dinosaurs were living in there. From 135 to 65 million years ago, it was the age of dinosaurs. Now, what happens during the Cretaceous period? Here you can see that almost the present day position of the continents has taken place. Only major difference is that here the India is still an island. So for a long time, India was not attached to any continent. They were in the form of India was in the form of an island. Here you can find the Australian continent, then Antarctic continent, and South American continent. They were all linked with one another. Okay, so let's continue. So coming to the Cretaceous period here, you can see that during the Cretaceous period, almost the present positioning of the continent has been established. Now here you can see that India is gradually moving. Now after 65 million years ago, and during that 65 million years ago is an important period in the history of the Earth. And during that time, there was a mass extinction of animals. All the dinosaurs got extinct during around that 65 million years back. The important reason is that a meteorite, a very giant, large size meteorite hit on the surface of the Earth, creating a nuclear explosion like event. It's like a mini nuclear bomb exploding together. Lot of soil and dust were released, and that prevented the sunlight from coming to the Earth's surface, leading to the cooling of the Earth. And this meteorite strike is followed by a cold period, and dinosaurs were reptiles. They are not mammals. They cannot maintain a warm body temperature. So if the temperature of the surroundings is gone down, their body cannot work. Even the modern reptiles are all poikilothermic animals. They are not warm-blooded animals. They are cold-blooded animals. So they cannot unless the temperature of the surroundings is around 20 degree or 25 degree, their body temperature will cool down. So that was the reason why dinosaurs were all reptiles, they all got extinct. So 65 million years ago is an important event, and during that time mass extinction has taken place. Now here you can see that this is the present day position. What is the present peculiarity? The only major difference that we are finding is that South America has moved more towards the northern region, and here you can see that this is the North America, this is the South America. There were once two separate continents. Here you can see that South America and North America joined together. Then another major event that we are finding is that Antarctica got separated from South America and Australia. Australia became more like an island. Whereas what happened to India is that India moved north, and India was striking at this region. That striking of Indian continent at this region resulted in, it's like two land masses coming and touching each other and pushing each other. And what will be the result? Lot of soil, lot of rocks will be pushing up. That pushing up of soil and rock resulted in the formation of what is known by the name the present Himalayan ranges. So, if even if you are knowing, if you are checking the surface of the Himalayan region, especially Everest and other continent, other peaks in Himalayan region, we can find fossils of oceanic animals. Because now it is easy because this was once a part of ocean. So right now we are still able to get fossils or remains of oceanic animals from the surface of Himalayan ranges because once that was an ocean. So these are the major changes that have taken place during these recent events. So when we are following continental drift, it is very easy to explain how Himalayan mountains have formed, why oceanic fossils are present on the surface of the earth, why the South American plants and African plants are similar. Here also, if you look at that, here the India was with near to the Antarctica as well as Africa for a long time. Here you can see that were all connected together. Even today, we can find a lot of plants present in Kerala region or South Indian region are closely similar to the animals present in this part of the Africa. On the eastern part of the Africa and the western part of the India, there is a lot of similarity in plants, animals, and also in rock structure. So all these can be easily explained if you are following the drift theory. So this is what happened during the continental drift theory. Now we can see that there is another closely related theory known as plate tectonics. There is not much difference between plate tectonics and continental drift. The surface of the earth is actually composed of major rigid moving crustal plate and several smaller plates. Here you can see that the basic idea of the plate tectonics is that the surface of the earth is formed of several major rigid and smaller plates. Here I have already shown you that plates. That plates I have here, I think I have. See, this is how the major plates of the earth are now appearing. We have different types of plates. There is Australian plate is there, then Eurasian plate is there, then Philippines plate is there, then Pacific plate. It is a very large plate. So Pacific Ocean is there. Then North American plate is there, Caribbean plate is there, then still South American plate is there, Scotia, these are all small plates, then Antarctic plate, then Australian plate, see Indian plate. So Indian plate is also a smaller plate. Then we have another smaller plate called Arabian plate. Then Caribbean plate. So many major plates are there. Along with the major plates, some minor plates are also there. So that is regarding the theory of plate tectonics. The surface of the earth is actually formed of several plates. Now we have to see some evidences. Some of the evidences I have already discussed with you. Few more evidences I will tell you. Then see evidences for this theory. So one evidence is that South America and Africa would fit remarkably well, shoreline to shoreline. Already I have shown you that. There is a close similarity between the shape of eastern side of South America and western side of our African region. Then that is if America were moved to next to Africa, there would be a match of ancient continental rocks and tectonic structures. Like that is the folding of the rocks or mountain. That is the meaning of the. Another is that Pangea. When Wegener placed all the continents together like puzzle, it formed a large landmass. Here again we can find that. This is the Pangea. It is now, if you can arrange all the continents like this, they will be matching with each other just like a jigsaw puzzle. So that is, this, see here you can see all the continents we can be closely arranged like this. That means once all the continents were together, then they got, so west coast of India. Here you can see the west coast of India, the Madagascar. See the shape of India and the shape of Madagascar, eastern portion of Madagascar are matching with each other. So seems to have joined the North America and South America on one side, and Europe on other side with other bit along the mid-Atlantic rim. So this is how the continents were once together. So they can be easily joined, and by simply studying the structure of the earth on earth, we can easily understand that once all the continents were together. Here the same picture is given in a different. Now another is the fossil evidence. There are some trees known as presence of glossopteris. Glossopteris is a vegetation present in different parts of, here you can see that. This is a this is a fern, a fossil fern. We have remains of this glossopteris from all the southern continents. That shows that once they were all joined together, that is, all the southern continents were joined together as Gondwana land. Here you can see that this Glossopteris is present in Australia, it is present in Antarctica, it is present in India, it is present in Madagascar, it is present in Africa, and it is present also in South America. So, if you examine the fossil evidence of this fossil fern known as Glossopteris, we can easily explain that once all these continents were joined together. Another example is the use of Lystrosaurus. Lystrosaurus is right now the fossils of Lystrosaurus is present in Antarctica, India, and Africa. That is, India was near to Antarctica once. So that is the only explanation that we can give. Then there is another is the fossil remains of freshwater reptile Mesosaurus. That Mesosaurus were obtained from the southern region of South America and also from the southern region of Africa. So these are the another fossil evidence, and we have one more evidence, that is Sinognathus. We have the fossils of Sinognathus from this region, the western region of Africa, and also the eastern region of the South America. So so all these fossil evidence clearly shows that once once all these continents were joined together as a Pangea, and there was two large continents also, Laurasia as well as Gondwana. Here, this is another event called shifting of poles. Earlier, I discussed with you. Right now, here this is the shifting of poles, otherwise known by polar wandering. Here you can see that the this is the ancient, the present geographical north. This is the present geographical north. That is around 100 million years ago. The magnetic north was here. Around 200 million years ago, the magnetic north was here, and around 300 million years ago, the magnetic north was here. So around 500 million years ago, it was very far from the present geographical north. So this movement of magnetic poles is known as shifting of poles, or otherwise known as polar wandering. If you are studying geology, you may be you may be able to study more about the magnetic shifting or polar wandering. So this is an important evidence in support of this continental drift theory also. Then why do plates move? There is another explanation also. We have to say One reason is that due to the tremendous heat, that is earlier on the first slide I showed you, the mantle, crust, and the core. The mantle is in a liquid situation. The temperature of the mantle may be around 1500 or 2000. So they are in a liquid situation. All the rocks present in the mantle are in a liquid situation. That we can easily observe that when a volcanic eruptions are taking place, this liquid or magma or liquid mantle is coming out. So that is due to the tremendous heat of the rock in the asthenosphere or in the mantle. That is converting all the solid rocks into a liquid rock, and on the surface of this boiling or boiling rock, boiling magma, the plates are actually moving. It is due to the heat generated by the liquid magma or liquid mantle that is resulting in the movement of the rocks. So the movement of the rocks is actually caused by the tremendous heat. The mantle itself at a temperature of 1500 or 2000, very high temperature. And that temperature is mainly responsible for the movement of the continental rocks as well as the continental plates as well as the oceanic plates. Then another is that convection current causes hot material to rise and expand. When two plates are actually moving away from each other, there will be a formation of volcanic island or volcanic mountain. Sometimes what happens is that two plates will be pushing each other, and what will be happening is one plate will be moving up above the other, and that also result in the formation of mountain. So one will be sinking down, other will be moving up. So that kind of events will be taking place. So sometimes plates will be diverging, moving away. So, what when plates are moving away, what will be happening? The molten magma or molten mantle will be moving up, resulting formation of volcanic islands or volcanic mountains. Sometimes they will be pushing each other, moving to each other, and as a result of moving, one will be moving down, another will be pushing up. Here you can see all the pictures of that. See, these are all the regions where this is one plate. Here you can see this is the all these regions with the red triangle are regions with intense earthquake activity, because this region, for example, the northern region of India, this region, right now we have an earthquake in Afghanistan. That is also an earthquake belt. So that is at the plate border. Here you can see this is the border of Eurasian plate as well as Indo-Australian plate. So now remaining we will be taking in next class.